decided to make a box which consists two compartments. So these two compartments, each compartment will fit by four ping pong balls, and we use a mounting board as a material for our box. And the dimension for our box, which is 14 and the 20 for the length and height 13. And then we attach aluminium sheet. This is aluminium sheets for the sensor to detect. And when sensor detect, the conveyor will stop moving and the ping pong balls will fill the compartments. So besides that, we use a clear plastic for the window as to observe the falling pieces of the ping pong balls. Yes.
Alright, hi, my name is Farah Aina binti Fauzi, and I'll talk about the flow of the machine. Okay, first of all, in order to start the experiment, we have to switch on those switches over here, the monitor and all. Alright, next, we have to run the coding through the Raspberry Pi software, and then we have to switch on the push button over here. Once the motor runs, the valves over here, the four valves will close, and then a few seconds after that, the conveyor will move from left to right, and will start once. The proximity sensor detects the aluminum plate. You can see the light over here, the red light. Alright. Once it detects the aluminum plate, the top valve will open to let the ping pong ball pass through to here. And then the bottom valve will open to let, after the ball has passed through here, the bottom valve will open to let the ball fall down into the box.
Okay, today I'll be explaining about the wiring of the experiment. So as you can see, this is the setup for the Raspberry Pi and also the project. This is the Raspberry Pi connection connected to the interface board, and this is the power voltage divider that is used to break down the power to be supplied to the sensors, which only requires 5 volts. As you can see, all these wires are connected with each wire is connected to GPIO and also the power source for the valve. And this is the circuit board, and this is the setup. As you can see, we use a PLC over here, and we use the power supply, the positive terminal to be supplied over here, and the negative terminal to be supplied over here. And all the positive will supply power to the valve, and the negative will take the ground from the GPIO and also the sensors. Yeah, thank you.
Hello, my name is Nadia, and I am responsible in writing the coding for our material handling system. So in this project, we are using Raspberry Pi 3B Plus with built-in programming software, and in this case, we are using Python 3. First of all, we need to import the necessary library that are needed to run our system, the library that we are using. So this Adafruit DHT is for DHT22 sensor. DHT22 sensor is used for detecting the temperature and humidity of our surrounding. 5 inputs. First is power button, magnetic sensor, right proximity sensor, left proximity sensor, and DHT22. So we have 6 outputs, 2 relays, and 4 solenoid. Both of the input and the outputs are based on GPIO numbering pin of our Raspberry Pi 3B Plus. So next is the input and the output setup. It is compulsory to declare which is the input and the output in order for the Raspberry Pi to be able to control both of them. This part is for initializing our output and inactivate them. So now we move on to controlling the conveyor movement. We define a function for conveyor movement. By creating function, it is easier for us to call them when we need to use them. Debugging process can be done easily as well, as decreasing the number of lines as we don't have to retype the instruction every time we need to use them. So we have three movements, which are stop, move to the right, and move to the left. This controlling involves sending the low and high signal to the relay based on the relay function and based on our wiring as well. So for the ball release function, we have two sides of ball storage, which are right and left. So these are the instructions for the ball releasing. Low or high signal is used in controlling the opening and the closing of the solenoid. This one is for the left part. And for the right part, it is an additional magnetic sensor that is used in controlling the opening of bottom right cylinder. So in our main body of our programming, this one is for waiting for the power button to be pressed. Start the system. And all of the solenoid will receive high signal so that they will open and they will close, and we can set up the ball. Conveyor L is used to instruct the conveyor to move to the left, and the first part of the ball will be released. As you can see here, ball L, one ball will be released each time the conveyor stops. The conveyor will stop to let the ball in every time the signal from proximity sensor is detected. It will move again, and the ball will be released in a similar manner each time the conveyor stops, as all of the programming are the same. This code will be repeated for all the 8 balls. So lastly, after all of the ball put in the storage box, it will stop. And finally, completing the process, we use the DHT22 sensor to read the temperature and humidity of our surrounding near the conveyor. And this is the instruction for the DHT22 sensor. And after finishing the process, and after the DHT22 sensor print out the result, the GPIO will clean up all of the instruction memory.
Real industry application, this conveyor well tagged as the real conveyor, which is used in the manufacturing production line to move the product from one place to another. As you can see, this sensor will first act as the stopping agent to stop the production line to let the ball fall into the box, in which in real process the production line is stopped and the product is let to drop into the box. Next, the sensor will act as the starting agent to let the production line to continue again. And as well as in the real process, the box is led to move to another place.